Okay, so in the last two videos that are there in the playlist, I was working on Kaggle competitions. For the first one was the house price prediction, and the second was the IEEE fraud detection. So now I'm going to move ahead to the tabular classification part. So we'll start with a quick start code that we have executed first. So basically, tabular data is nothing but it's like kind of structured data typically stored in like tables or like CSV files. So this is how we work on that kind of data using Autogluon. So the first step would obviously be installing Autogluon, which is what we have done. And then over here we're getting the tabular data set and the tabular predictor from the autogluon.tabular. Oh, and then here we're loading the data. Just given a URL and then we're getting the from the data, we're just splitting into the training one. And then label is nothing but this is the target that we are setting. So yeah, so this is a predictor part where we're using the tabular predictor, setting the label that is the predictor, and then after that we're just giving the training data. So this is where all of the models will be compared. And so yeah. So AutoClone automatically tries different models, optimizes their performance, and selects the best one. So that is something we don't have to do on our own. So this is all of the evaluation. That does automatically like checking the validation, training time, and checking the accuracy, etc. So after that, we're just using that whatever was trained, we're using that to predict. So if you can see -2, -4, and all of these are the predictions. And then the accuracy that we got for the test data that we tested was 0.95, which is really good. And then Autogluon also provides a leaderboard that kind of ranks all of the different models it tried. And it also kind of shows which was the best model it chose. And yeah, so let us go into depth. Okay, so in this in-depth uh, collab, I want to talk about how like we can get a better understanding, like we can deep dive and more hands-on understanding of how Autogluon works. It basically shows us how to train models, tune them, evaluate the performance, and also customize the process if we want any specific needs. So like maybe let's say hyperparameter tuning, we want something else, or like ensampling or something. So we can do that on our own too. So this is kind of like deep diving into the uh, tabular predictor, but kind of in depth. So as usual, just install the Autogluon. So here we're just installing the tabular model. So from that, get all of them, and then this is the loading part, and then we're just splitting the test data over here, and then the training data, we're just taking a sample from the train data, and then we're getting a test data, and then we kind of deleted the label column, which is nothing but the predict column. So yeah, this is the hyperparameters that we have over here. So we can modify these. And then this is where the predictor is coming into the picture, setting the label and then fitting it based on the training data. And then whatever hyperparameters that we want, we can set them like this. So basically what we're trying to prove is we can also modify whatever Autogluon already has based on our needs. And then all of the validation and then getting the best model out of all of the models is done over here. And then this is the fitting part. So these are basically the results. So now we're just predicting the class, like the binary classification, whatever we're trying to do. So we're going to predict that. This is that. And then here we have a few other parameters that we're changing again. So the results of this are here, and then after that we are doing something else with the same data. So like predicting the class. So here we're just predicting, and then after that we have printed the leaderboard for setting up the best model. So as you can see, and then we're just calibrating over here, getting the scores of all the metrics that were trained. Mm. And then loading it. So we're saving it here, getting the best model which was trained previously. So as you can see, weighted ensemble L2 was the best model. Yeah, this one. So yeah, basically we're just checking how we can like get in our own perspective into this particular Autogluon thing. So that is what we're trying to do over here. Yeah. So here I think the same data, we have set a time limit and we're doing something else. So basically we're just trying to play around with whatever changes we can do and then ensembling and all of that. So how many uh how many rows it was able to predict in what amount of time? Like we're just testing the accuracy, I would say. And then here we just printed the leaderboard again. So here we're setting a smaller time limit because this is a small data set, I would say. But if we want more accuracy and all that, we can obviously like set more time. And then we're setting the presets over here, good quality and optimized for deployment. We can also change them to best quality or anything else. And then the hyperparameters are set to very light. This is the predictor part again. So we can also make it faster by kind of excluding a few model types. Like if we don't want NN dots and KNN, I can mention these, and then like I can send it as a parameter saying I don't want these models. So that is what we're doing here. It'll actually make it faster. So yeah, this is how the in-depth Autogluon works. Thank you.